How do we use angles of elevation and depression? Well, first let's define those. An angle of elevation is the measure of the angle from the horizon up. Right, so the angle of elevation would be right here. And then the angle of depression is the measure of the angle from the horizon down. So this is a horizon, and from the horizon down, this would be the angle of depression. And because horizons are always parallel to each other, the angle of depression and angle of elevation are always equal to each other. Now, just in case you're wondering what you're looking at, this is a guy looking at a hot air balloon far away in the distance. So, I've got some mad art skills here. Let's try some problems. All right, let's find the horizontal distance from the man to the balloon. So, what we see first here is that the man is 6 feet tall and the balloon's 250 feet above the ground. Well, then the triangle I'm actually looking at has a height of 244 because we have to take away the 6 feet from this guy's eyeballs. Okay, so he's looking up at an angle of elevation of 35 degrees, got this 244, and we're trying to find the horizontal distance, so this x here. Well, if I have an angle with its opposite side and I'm looking for the adjacent, well then I need to use tan. Because I know TOA, right? Tangent is opposite over adjacent. So the tangent of 35 degrees will be the opposite, 244, over the adjacent. And after doing some algebraic rearranging, making sure my calculator is in degrees, I get that x is equal to 348.47 feet. So the man is 348.47 feet from the base of the balloon. All right, what if we hadn't done that problem and I just wanted to figure out the distance of the line of sight, this distance? Well, then this would be the triangle I'd be looking at, and I would need sine since I have an opposite and hypotenuse. So we set it up, and x would equal 244 divided by the sine of 35. And so x would equal 425.4 feet. And notice that this was bigger than the horizontal distance, which is a good thing because this is a hypotenuse, so this needs to be larger than each of these numbers. If you ever get something that's not larger, then you messed up somewhere. All right, so let's look at this problem and label things as we go along. From the top of the lighthouse, 165 feet above sea level. So this distance is 165 feet. The measure of the angle of depression of a boat at sea is 42 degrees. So with this horizon, this angle of depression right here is 42 degrees. Find to the nearest foot the distance from the boat to the base of the lighthouse. So this distance right here is what we're looking for, x. And we should see that if this is 42 degrees, then this is also 42 degrees. Now this looks a lot like the last problem, so pause the video and see if you can figure out x on your own. And alright, hopefully you got it down to x equals 165 over tan of 42, or 183.25 feet. Alright, a cable is used to support a television tower and is connected from the top of the tower to the ground at a horizontal distance of 400 feet away. If the cable is 750 feet long, what is the angle the cable makes with the ground? Alright, so I've drawn the tower, the cable, and the ground. Now I just need to figure out what is this angle right here. Well, for this I'm going to have to use cosine. The cosine of theta is equal to the adjacent over the hypotenuse. So to actually find theta, I'll have to do the inverse cosine of 400 over 750. And I see that the angle that the cable makes with the ground is 57.77 degrees. All right, finally, let's try a challenging problem. There's a lightning rod on the top of a building. Yeah, and look at this awesome lightning. From my location 600 feet from the base of the building, the angle of elevation to the top of the building is measured to be 30 degrees. From the same location, the angle of elevation to the top of the lightning rod is measured to be 33 degrees. Find the height of the lightning rod. So basically, here's what we have. We have two different triangles. This to the top of the building, this is 30 degrees. And this triangle to the top of the lightning rod is 33 degrees. Both of these have a base of 600. So what we're going to need to do is find the heights of each of these triangles, and then we'll just subtract to find this little bitty distance in between. Let's start with the green triangle to find its height. That would be the tangent of 30 degrees is equal to the height of the building over 600. So H is equal to 600 tan 30. So the height of the building is 346.4 feet. We can use the same method to find H2 is what I've called it. You can call it whatever you want, which is the height of the building with the tower. Okay, and doing this, we get that H2 is equal to 389.64 feet. So, how tall is the lightning rod by itself? Well, that would just be 389.64 minus 346.4, which is 43.24 feet. All right, and that's all for angles of elevation and depression. Goodbye.